Hello, my name is Sean Gallagher, and I'm making this short video on behalf of Software Toolbox to document a quick proof of concept demonstrating the ability to take the DNP3 map from an FP3000 device and use that to create a tag namespace in our top server OPC server. So we at Software Toolbox have developed and are continuing to develop an EFM exporter for the FP automation platform. So we have software that can automate the retrieval of the EFM historical data from these devices and export that data into a Flocal CFX file, and we also support exporting to ODBC compliant databases. That software uses our OPC server, top server, to get that EFM data. So what you're seeing here is top server. You can see that I've got a channel and a device to my test RTU, to my FP3000, and there's really no namespace to speak of. I've created a system time tag in here, basically just to test communications, and I've got some file control tags created as well. This is what we use to gather the EFM data. Gathering EFM data from these FP automation platform devices uses the DNP3 file control capabilities, and so we just pass parameters to the RTU, it sends us files, and then we parse the files, etc. So what the goal of this proof of concept is effectively to create a namespace in top server that would allow a client or SCADA system or whatever to browse this OPC server and be able to address parameters from the device without having to know these addresses. As you probably know, DNP3 is a relatively new protocol being used in the oil and gas market, so there's not a lot of understanding, I would say, of it. Was actually new to me as well when I got into it, and I've been in the oil and gas industry for over 30 years. But understanding how to address parameters from the device, we'd want to do it in a more easy to recognize name versus having to track down what this address is. So the goal of this proof of concept was to effectively get a namespace built within the OPC server. It has capabilities to do imports. So from a proof of concept standpoint, all I was trying to really accomplish was to get an export of the DNP map from the RTU and import it into here. So let's jump in. I'm going to start my connection to the RTU. I've got a lab RTU that is on the network, and I'm just going to open up FBX Connect and connect to that device. We'll give it a chance to actually do its connection. And I'll let you know that I'm not an expert on field tools, so I'm going to go through some very rudimentary stuff within field tools just to kind of show you what I had to do. But it was pretty easy once you kind of understand the concept. So I need to get to the DNP map within field tools. So I'm going to go to the port that I'm communicating on to this particular RTU. A couple of places I can click to get to the DNP map. I'm just going to click to it. Click right here, DNP3. And my friend from Emerson, Steve Hill, exposed me to something that is available with the DNP3 mapping called auto-managed DNP3 mapping, which allows you to create templates that could be very specific to a particular RTU or particular system you have, and I can have multiple templates, etc. So effectively, I'm taking advantage of the templates. Now, this is a test RTU, so it's not something you would see kind of in the field. I've got 4 DP meters configured. I've got 3 linear meters, and I've got 2 liquid meters. So I've got a little bit of everything so I can do testing. So I'm going to have a DNP map that's going to cover all of those. So if I look at my template here, I'm just going to click on Edit Template. This is the template that I'm using for my DNP map. All I really did was I imported a standard configuration template file. Obviously, you can customize this to your needs. If I didn't have RTDs, I could disable that so it wouldn't map those to DNP addresses. But once I get this the way I need it, then I can save the template file, and then I can click on this button here to generate the DNP map file. So once the DNP3 map file is created, I can view that DNP3 map, and basically it shows me where everything is mapped to from a DNP addressing standpoint. So all of my binary inputs, my outputs, my analog points, my counters, my strings, I don't have any counters, but my strings, etc. You can see that these are the point indexes for, and you can see this is the object group it's in and the variation. So all of that information is here, and then I can export that. And when I export it, it exports to a CSV file. Just for time's sake, I already have that CSV file open, so I'm going to open that up. This is what the export file looks like. It's very simple. It basically tells me, the type of point, which is the table. It gives me a point index, which is important for the DNP3 addressing. A device parameter, which actually I'm going to use as my tag name, and then information that is DNP specific, the class, the variation, etc. So you'll see out here to this, I'm going to expand this out, and you'll see I used a very simple Excel formula. Concatenate, and basically what I did was I just concatenated a string together, and this is going to be my DNP3 address that I'm going to use in Kepserver to address the points to the RTUs. So I could probably get a bit more sophisticated with this, but I was just doing something just quick and dirty. So I hard coded in. I know that a binary input is coming from group 2. I know that a binary output is coming from group 10. But the rest of it I'm concatenating the variation. You see that there, the 2, and then I'm getting the point index. And then I'm putting as DNP3 dot explicit is one of the ways to address a point within the device. So once I have that, I just drug it down, and I've got that for all of the points that came as part of the map. Your map may not be this big, but again, this is a test device, so I have a lot of different types of meters in here. So I've got basically everything for my liquid meters, my linear meters, my DP meters, etc. So once I have that in a CSV file, it's a matter of just copying. I'll open up, again for time's sake, I already had an import file created for my OPC server. So you'll notice that here's my file control tags that I have in my OPC server. So I exported from my OPC server to get the structure, and a lot of the stuff I really I don't necessarily need. But all I really did was I copied the device parameter here, pasted it in as the tag name, copied the address from here, pasted those values in for my address, and then really that's it. The rest of this is I just left the default data type. It'll pick up the data type that it needs when it goes into the OPC server, just a scan rate, etc. So once I save this file, I'm going to close this out, and it's already saved, so I'm not going to hit save again. And I open up my OPC server, and if I right click on my device, you notice that there's this import CSV. I'm going to import CSV. I'm going to select that CSV file, and I'm going to open it, and boom, almost immediately, all of those tags were created, and the namespace was created. Now, because I have, let's say DNP meter 1 dot flow direction, it actually it uses that dot to create a tag group for me. So if I were to go to DP meter 1, you'll see that all the tags are created underneath that with all of the proper addressing. I could go immediately, let's just go to something that's moving. So we have our own OPC quick client, but this could also be any other client connecting to this OPC server. I'm going to launch the quick client, and you'll see immediately data starts coming in. The only thing moving is seconds, obviously, but you'll see that the seconds are moving. Close this down. If I wanted to go look at my DP meter 1, I can look at all of those tags. I'll launch quick client here. All the information immediately comes in. So I'm connected to the device with my OPC server, getting data from the tags that I imported in. So if we wanted to just play around a little bit, let's just look over here, get some stuff out of the way, and leave my quick client up. going to cancel out of this and just play around a little bit. I'll go to my configuration, let's say for DP meter 1, since that's the one I'm looking at. And you'll notice, I mean, there's nothing in there for description. So if I wanted to just, let's say, call this DP meter 1 and save that, you'll see it immediately updates in my client. So I'm connected. I'm passing data to that RTU. It's showing up in my field tools. It's showing up in my client. With this is a read write. So if I wanted to, I could come in my client and I could do a write back. And let's change that to meter 1, 2, 3, 4. And you should see it change in field tools. So that's changing in the RTU. So I'm doing read and writes back and forth to the RTU, and really that's what I wanted to accomplish. I'm going to close this client out. I wanted to accomplish building a namespace in my OPC server that would be then accessible from any client connecting. It's browsable. If I had a client that had browsing capabilities, it could browse into the OPC server and look at information that is more understandable. I can look at VP meter 2 and look at my energy rate tag. I don't have to know necessarily this address, which is really what we're trying to overcome. Apparently, really the challenge in the industry is because this is a new protocol, and even if it wasn't a new protocol, I don't want to really have to know what all these addresses are. I need to know it by something that makes sense to me. So that was the goal, was to very quickly be able to export using standard tools that are part of the software. The export capability is built into field tools. The import capability is something we have within our OPC server. And so the goal was to be able to get data out of, get the DNP3 map out of the device, and then import that into my OPC server and create this namespace. So hopefully this was helpful, and thanks for watching.